So how are you doing?
Good. How are you?
Good. Have you done an interview with IK before?
Mock interview? Yes, I have done mock interview with IK. Yes, in previous weeks. Yeah.
Gotcha. Okay.
Mm-hmm.
Cool. Cool. All right. So let me just pull this up. I see that you're on the code bunk here.
Mm-hmm.
Um,
Yep.
can you also share your screen when you're ready?
Cool.
All right. And then let's see. I have here saying that you want to do a recursion.
Recursion. Yes.
Okay. So, um, all right. So let's see. Let's go ahead and get started here.
Mm-hmm.
All right, so let me know if you've seen this problem before. If you have, we can do a separate problem here, a different one.
Sure.
So here is the question here. So, and then let me give you some examples here.
Mm-hmm.
So, yeah, this problem, basically you're given two strings, word one, word two, let's say, and basically you want to return the minimum number of operations to convert word one to word two. And you have three operations, right? You have insert, delete, and replace, right?
Okay.
So in this example here, let's say from here to here, right? From Horst to Ross, what are the operations you need to make? The minimum number of operations to make Horst turn into Ross. And output here would be 3 because you would need to, there's many, different types of examples here, but for example, this one, if you replace the H with an R, right, it'll be this, Rors, and then if you remove the R, you can get Rose, and then you remove E, right, you get Ross. So the output here would be 3.
Okay, I see. So the minimum number of basic operation, right? So okay, so there could be multiple. First of all, I never seen this problem before. Second, I think the so basically, even those minimum number operations, so but there may be multiple solutions, right? So there are multiple way to get there, right? So with the minimum 3.
Yeah, exactly. Yeah, but
Right,
you want
right.
the minimum number. So even if it, same as 3, the output is still 3, right?
Okay. 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 So let me. Is that possible? Okay. So is that possible? There's no way from word 1 to word 2, or
Yes.
you assume that always there's a way to get from word 1 to word 2.
Actually, let's just for now, let's assume that it's possible.
Possible what?
To
Possible.
possible to get from word 1 to word 2.
So you're saying always possible, right? Word
Yeah.
1 to word 2.
That's
Okay.
right.
So so word 1 to word 2. So we're I mean, so the word 1, word 2, the okay. So the word 1, word 2 is so the length of word 1, word 2 is, I mean, it could be, there's 3 possibilities, right? So word 1 the length is greater than word 2 or equal or less than word 2, right? So
That's right.
yeah,
Because you
okay.
can insert, right? You can insert.
Is
So
that possible you get a empty word, I mean empty string for one of them, or
that's a good question.
or for
Yeah,
both of
so
them?
that's possible, right? Let's assume, if you have word 1 as an empty string, right, they would all be inserts to get to word 2, right?
Then the minimum number operation would be 0, right? So
well, it would be 3 because if this is empty, right?
Oh, okay.
Then
Yeah.
right,
That's true.
you would
That's
have
true.
to
That's true.
insert
Right.
3.
Yeah, that's right. So you have to insert 3 times. Yeah, understood.
That's right.
Okay, cool. So okay. Alrighty. Let me see. So let me think of an approach and the possible data structure to use. So let me Okay, if you don't mind, I'll probably come up with some additional examples. So that, just help me think, find up some certain pattern, and then.
Sure.
So we're one. Okay, so maybe example 2 might be. Okay, war 1 is okay. So war 1 equal to. Okay, so. Okay. Also, the number of operation. Do we assume the number of operation we apply them in order, meaning that for example, if I want to remove the first character and maybe add a character between the second and the third, so basically we, instead of just randomly perform the operation, do we assume that we perform the operation in sequence, right? So like from the least with the smallest index to the largest index, or we can apply.
Not necessarily. You could do it at any
anything.
order.
Okay.
Yeah. You could do it at any order. That's right.
Any order. Okay.
Yeah. So you could remove the R, remove the E, and then change the H to an R, right? That would be like almost a different order of this, right?
Okay.
Like this is just an example of an order. You could do any of 3 of these in any order and you would still get the same result, right?
Okay. So, replace H with R, and then remove R, it becomes OS. Okay. So, so the input is, so the input is 2 strings, and the output is the minimum number, is an integer, which is the minimum number of operations to perform. And there's only 3 operations I can perform: insert, delete, and replace. Okay. So let me see. So I think so. So I'm just brainstorming. So the solution may or may not work. So if I do a sequential transverse of the first word, and so what if I what if I do a sequential transverse of the first word, and try to find the letters in the second word, then try to decide. So if I try to traverse the first string, and then for each letter I will try to find out whether it is in the second string. If it is, it should stay. If it is not, then I can try. I can remove that letter. So, that's interesting. So if I go to the first word, assuming it's not empty, so traverse the first string, then how do I remember? So how do I remember? So hopefully, let me see if there's a brute force way to, so if I traverse the first string, And okay, so return minimum. Okay, whatever. So return. Okay, so whatever that is. So minimum ops. Yeah, just randomly give it a name. So the okay, so the input would be, so it just to word, then okay, then the so there should be a, okay, so there's minimum number of operations. So at the end I'm going to return that. So then what is the, okay, so this, I assume there's something to do with recursion. So okay, so if I, okay, so if I,
maybe it'd help if you maybe think of like a very simple word, right? Let's just say, like a 2-character word or a 1-character word or something, or like a 3-character word or something very simple. Maybe that can help you, digest it a little bit better.
Okay.
Simple even just word. Like A, B versus A, something very simple, right?
Okay. Okay, that's good. So that's okay. Okay, so if if the second word is, okay, so if the second word is a substring of the first word, then you can just drop I can just drop the remaining character, but it could be other way around. So the so there could be the other way around. So the second word is longer than, okay, so then I'm just I just need to add and try to find some kind of a pattern. So okay, so if I traverse the first word, try to find this one. Okay, so
yeah, okay, and you want to think of the 3 operations, right? Like, what can you do with these 3 operations?
Okay, so if okay, so I certainly want to traverse the first string, so that if traverse the first string, so if 2 point, so I can traverse the first string. Then if that particular letter is also in the second string, then I can just move to the next character. If this one's right now I'm a little clueless, but so if I traverse this string, then traverse this string. Okay, so then I will find, okay, so then if I find, okay, so if I find the okay, so I traverse this string, so if I traverse this string, so if I'm, so traverse this string, if I'm,
what would be the first operation? So when you traverse it, you're comparing what?
I compare the letter in the first word.
Okay.
And
so you're comparing A
with
to
the corresponding. Maybe it's like
okay.
2 pointers, right? So one pointer point to the position, A, and the second pointer point to the corresponding location in
Sure.
word 2. So look like they're the same. So nothing I need to do. So then I try to move the pointer to the first word to the next letter.
Okay.
Then word 2, I'm already running out word 2. Then so that sounds like I need to do a delete, right? I just delete the.
So let's note down, what are you comparing to what to identify that you need to delete in this case? You're comparing what, the character B to what?
To the character B to, because this is already second string already out of
right. So
range,
it would be,
right?
you're comparing to essentially like an empty string, right?
And empty string, yes,
empty
string. So because it's already out of, so it's basically compared to empty string. So and because it's compared to an empty string, so then at that point I think I need to do a delete, right? So because the second string doesn't have the second letter, right? So that obviously is a delete, right? Then I just add a counter of operation just to 1 in that case, because the second string is already out of bounds. So then that means I should be done at this point, because there's nothing either add or delete or replace I need to do, right? Because I'm already out of range. Yeah. So yeah.
So I think that's pretty important, right? Let's you're basically identifying the base cases right now, right? So the base, like maybe you should write down or kind of note down what are the base cases of when you should do which of the operations, right?
Okay.
And so that was for the delete case.
Yeah. Right? So maybe I need a. So sounds like I may.
You can just write it down, like in the notes section, just like what are you observing?
Maybe I need a. Well, this is if this is recursion, so I may need a basically helper function. So basically I need a base case and a recursive case. Yeah. So so my base case would be.
So there's 3 operations, right? Remember, we just talked about which operation.
We just talked about a delete, right?
Okay,
so it sounds like we
note that down. Yeah.
Yeah. So maybe I have. Sounds like I have 3 base case.
Right.
Right. So if so, but here I think I need a. I need maybe a character, I think.
Well, how about let's not try to jump into the code yet. Let's just write down the examples of what we talked about. All right, and identify that. Let's not jump into the code yet.
Yeah. So the first one is the first base case is.
And you can give an example, like the example that we just had earlier. Let's just say, for example, is like a B and an empty string, right? So maybe a B and an empty string. This is when you be deleting, right?
Right. So the word 1 becomes become B and word 1 is empty string, right? Because it's out of bound.
Right. So that's so this
I
would
compare,
be delete.
Yeah, I compared to the word two, there's nothing, and the so then in that case I will be basically delete, right? So
Okay.
I'll be deleting.
Right.
So I think there should be two other base case, which
Right.
is insert and replace.
Right. So let's
right?
let's note those down. Yeah.
Yeah. So maybe I just write some kind of a pseudocode, but
you don't have to think of any pseudocode yet. Just think of the examples, and then that will kind of guide you, right? So this case here, this example, word one, word two is the delete. Now let's think about the other two.
The other one that's insert would be insert a character would be like word one. The other way around, I think for example, if the word one is empty string and word two is it's like there's a B, right? So obviously in this case, I certainly need to insert I certainly need to insert a B.
Perfect.
Right. So and the third case would be basically replace. So that means it's both words have a one letter remaining, but are different. There's a difference. So I just need to replace the second one with the first the letter from the first word. So the third base case would be, so this one is, for example, this is a C, and word two, it may be a B. So they both have something remaining, but they are but they're different. So in that case, I would replace B with a C. Right. So and that's the base case. Yeah. So I'm not sure if there's any backtrack.
So this looks good, right? So you have three base cases. This looks good, right? Now, I guess like one thing to remember is that like I'm not asking you to tell me what the operations are, right? I just need to know how many of the operations are happening, right? So I'd actually, in the output here, I don't really care if it's a delete or insert or replace.
Right. I'm not doing the operation, right? So basically, I just add a counter, right? So I do need some kind of a counter, right? So that tell me, okay, so in this case, I do need. So I think in all three cases, so I think there's a common denominator. So if any of those happens, I should just add a counter. Just add a one to the counter, right?
Good. Yeah.
So I don't need to do one for each. So I think so I just type count, right? So just so in any of those cases, if any of those happen, that means I just need to add one, right? So now is the recursive case. So the recursive case would be, let me see. So the recursive case would be if the, let me see, if the current I think there should be so the recursive word I need to reduce. I think I need to remove, maybe if I compare both of them from the beginning. Okay, if I compare them, both of them come from the beginning. So I need to replace the first. I think I need to replace the first letter. So what? Okay, so first letter. So, and I do need to have some kind of counter to count. So, but for this letter, I just remove, for this letter, I just remove, I do need to compare the two. So what if those are, those are, okay, so what if those are different?
Maybe you can use the example we had above earlier where it's like A, B, and A, right?
Yeah.
So like the ones that you have down there are the base cases, right?
Yeah.
A, B with 2 characters would just be the next, would then showcase that you need some sort of, repeat of these base cases, right? Or, some kind of check.
So some kind of check. So if, so I'm just checking if, if there's something in the first letter of the word, which is 0. So if this is not now, and if that not now, but I do need to, so okay, in that case, in that example, so AB, so if maybe equal to, okay, word, so at the same position, they have the same character. So if that's the case, okay, so then I just ignore it, right? So I just ignore it, move to the next, move to the next iteration, move to the, basically the smaller string. So okay, so if they're equal, then I'm just remove the same letter, the letter, the character from the same position, and move the remaining of the string. But what if one of them is empty? So in this case, the second word is empty. The second word is empty. Okay, so so there's several recursive cases. So if they are, okay, same position, the character are the same, and there is, and there's something on the of the okay, so there's something on the second, on the next, there's some character in the, so if there is something in the next character, if there's not, if there, if there's not, if there's nothing there, then I maybe just pass empty, maybe I just pass an empty string, or if there's nothing there, I'm just passing the empty string. Else, so else, I'm just, or else I'm just, okay, so else I'm just maybe pass the word without the first character.
Maybe you should have those base cases there to check first before you do this, right? Like if those basic cases are, if those are base cases, aren't those usually the first thing that you need to check?
What do you mean by base case there? You're talking
like
okay.
You have the three base cases.
The base
Those
case,
are
right?
the first three things that you need to check first, right?
Oh, so instead of
so you're okay. So you're just coding up the recursive part right now, and
the
you haven't
recursive part,
done,
yeah. So
okay.
I assume that the base case part is already or it's already there, right? The straight recursive part is already there. I'm just just try to come up with the algorithm for the recursive recursive part, right?
Okay.
Okay, so so the this is okay, so this is the base. Okay, so base case word one, word two. Okay, so so look like there's three possibility here, right? So one, okay, there are a number of possibility. One is they're equal. Look like those are base cases. So at the recursive step, so there's a couple possibilities. One is the current letter, they're equal. Second possibility, there's something at the same book, but they're different. They're different. They're different letters. Third possibility is they are. Third possibility is they are. One of them is empty string. So one of them is empty string. Wow. Okay.
So
I'm not sure
that
I'm
maybe
doing
what you're
on the wrong.
confusing yourself.
Say it
I
again.
think what you're confusing yourself here is you're doing this if check here, and then you're doing the if check here, right? So when you're doing something like this, it seems like this actually here should be part of the base case, right? So you're kind of, so that's why I said maybe you should try to think about how to do this part first, which will identify which cases you have to think about in the recursive part, right? Because this technically is one of your base cases, if you're looking at this correctly, right? If there is not word one, which means it's empty array,
right? This
right?
is
That's
this looks to
actually
me, yeah, this looks
that's
to me
actually
like
this part.
this looks to me is actually base case right now.
Exactly. So
Yeah,
you're confusing yourself
confused.
with
Yeah, so
where is the base
I'm doing.
cases.
Yeah, so I guess I'm confused myself with when I do the recursive step, I'm doing actually the base case step, right?
So
that I'm repeating the base case step, right? Here.
Yes, exactly.
So yeah, so actually I don't need to do that here. So those are, so whatever passed in, so
so I guess my point here is if you write out what your base cases are first, it may help with how you want to think about the recursion part. So that way you don't confuse yourself.
Right. So basically, yeah, so the base case is yeah, I think the base case is there the base case, there shouldn't be a four base cases. One is the first two, meaning that one of the one of the word is already out of bound, and the third base case is they both have something in the same location, but they're different. So that's why there's a fourth base case, which is they have the same character. So in that case, in that case, you just don't need to do anything. There's, you know, so so there's full base case there. So so I don't need to, so that means I don't need to, so I don't need to handle them here, this logic here. So it's already assumed that it's already handled in the base case. So I just need to kind of reduce and conquer. So just remove the first character from the from each word. So yeah, so I just remove.
Well, you still need the first check, right? The first check was if the characters are actually equal, right? That's when you actually get your recursive function.
So okay, so you're saying I still need to check whether they're equal. If
Right.
it is equal, then I just remove this character from both array, right? Which is from
right. Think about the example 3 that you have, A, B, and A, right?
A, B, and A.
So
Yeah.
A and A are equal.
Yeah. Then I just remove this character from this word, right? So then word 1 becomes the word 1 would become just a character B, right? So then word 2 become empty string, right? So
and then that would be your base case.
That would be that would be my base case.
Right.
So but yeah, so but assuming, what if I have a C here, right? There's nothing. So if I compare the first position, I mean, at index 0, they're not the same.
Right.
Oh, then we're replaced. Okay, then
exactly. So that would fall into under one of your base cases, right?
As a base case as well. Yes.
Yes.
Correct. Okay. Then in that case, do I? But in that case, then what do I? Okay, so I'm supposed to. Okay, so okay, if okay, so I still need to compare. So if the character at the same position is the same, then I just remove them from both words and pass to the next recursive call. So okay, then if they're not the same, but the base case is is a scenario where the word has only one letter or no letter, right? But this may not. I'm not sure this is my. So if the index 0 here and here, they're different. I pass to the next recursive call, but this is not the base case, right? The base case is where both string, either both left with one character or one of them just become empty.
The replace character is also one of your base characters, right? So you're comparing A and C, right? You're comparing A and C, or let's just say in this case, right? You're comparing the first character, which is A and C.
Right.
Right. That would fit under your replace base case, right? Because A and C are different, which means you have to replace one of the characters. So you would have to turn A to C, let's say, right?
Yeah, that's true. Yeah.
Okay. And then after that happens, what is next? Next would just be, you would then be comparing B and what? Empty string. Right?
Oh, okay. Right.
Because you've already handled the A and C, right? You've already handled that.
Right. Then I just move on to to the next character.
Right.
And then the next character gonna be A and C already out of the way, so then only leave with B and empty string. Right. So then that's another base case, right?
Mm-hmm.
So sounds like there's maybe a while loop. I mean, traverse the both words, and for each character, instead of passing the whole string to the next recursive call, I'm just passing one letter to the so basically, basically it sounds to me like there's maybe a while loop here. So just traverse basically. Okay, so there's a while loop and traverse one letter at a time.
Mm-hmm.
And then the recursive call is just pass, instead pass two words, basically pass a single character words, right, to the next recursive. So what I meant by that, it was is so it's like okay, so the basically I'm just maybe use a for loop. So this one so I'm just maybe just traverse one of the words and so then just compare the corresponding location with check whether check where okay, so I'm just traversing one of the string, and then just passing, because just passing the corresponding location of that word. Then when it caught itself, then it really just handle the just handle the base case, and then just I don't even need okay, so alrighty.
I think you were pretty close with. So I think what time is it? Oh, so we got about 10 minutes left.
Yeah,
right?
yeah.
So
I think the recursion and dynamic programming, I think that's my and also graph probably. It's it's really it's a little difficult for me. So, but
yeah. So I think you've noticed that like whenever there is a say a recursion solution, like this is a recursive solution that you actually almost had it. Then you thought about going with almost like an iterative, or not iterative, but like a while loop, which is the more maybe efficient way to do this. But you still want to like you were on the route to doing this the recursive route, And then you could think about maybe this is the more optimal way to use a pointer instead of passing in the string.
Yeah,
but what you
like
had
a two
earlier
pointer.
was
I'm thinking of it using 2 pointers.
Right, but what you had earlier would have worked, right? So ideally, it would have been better if you had just stuck with that first and done that way, right? So
okay,
I mean, you pretty much had it, right? Like what you had earlier was you wanted to do a check, right? You want to do a check.
Sure.
It was like if the word, say word 1 of 0 is equal to word 2 of 0, right? So that's the first part, and then you would call your helper function. It was like I think you did like helper of word 1, right?
Okay.
And word 2, right? You did this, right?
Yeah. That's right.
Right. So this is correct, right? Because you're basically trying to do a helper function through and calling this through. So
Okay.
you're like it's pretty correct here. The only thing that I think what probably tripped you up is like you didn't actually code out the base case.
Right.
So you kind of figured out what how the recursive function works is like, okay, you compare these. If they're equal, then you call the recursive function on the next words available, right? Which then, so you would be calling like if let's just say a function of A, B, right?
Yeah.
A, B, and C, right? Then you'd be calling function of what? B and empty, right?
Yeah.
That's the idea.
That's right. That's basically you kind of decrease and conquer.
Exactly.
Make the problem smaller and smaller until you reach the base case.
Right.
Yeah, I think the hard. I mean, usually I can come, even it's doing an interview. Usually I can come up with something, but this one, what's difficult for me is it have multiple recursive, multiple base case.
Yes,
think about,
and that's probably what
so
made it
that confused me.
right?
Yeah, so that kind of confused me, from the beginning, right? So
right, yeah. So, but
yeah.
I think this is good practice, right? Like
definitely,
if you
very
can
good
master the
practice.
fact that there's multiple base cases,
yeah,
all you actually have to do. So this is the solution, basically the recursive solution, right? Like the base case is if the words do not, if basically the word 1 and word 2 do not match, or I mean, sorry, if they're empty. So in this case here,
right,
this is when the empty word. So that's why I ask you to write them down, right? Write these base cases down to kind of identify what these are. So this is when you're comparing empty to empty, right?
Yeah.
There would be no counter to that, right? That's just like equals, right? And then 1 is if word 1 is empty, right? So that would actually be this case right here. You would be inserting, right? Because if you think about an empty word 1, you would have empty, and let's just say you have ABC. You're going to be inserting ABC, all three of them, right? So it doesn't matter what happens after. If word 1 is empty, right, then you're actually your operations are just insert, all three of them insert, right? So that's why you return the length of the word 2, right?
Okay.
And then same with this, right? Like if this is ABC, right, and this is empty, you would be removing all these characters to get to here, right? So that's why you would be returning the length of word 1.
So all of this are base case.
Yeah, these are
part
the
of the basic case. Okay, all of them.
Yeah, these are all base cases, right? And then including here, right?
I see.
If the word is matching, then you would call your function again, just like what you did here, which is going to the next word, right?
Okay.
So that's it.
I
think the trickiest part is here. It's like if the words do not match, right? So that's what you were saying.
That's right.
This is where you would be trying out a few different things. When the words don't match, you have a few options, right? One is you can either replace the character, right? Or you can insert the character, right? You think about this case, right? Like if it's here, one way you could do is like you can insert B, let's say, right? And that would be one operation. So one operation is you can insert the same word, or you can delete the word, the first word, or you can replace the entire word, right? So there's 3 different options of what you need to do when the words don't match, right?
I guess one.
Right?
Yeah, go ahead.
Yeah. No, I'm just saying. Yeah, so that's the idea, and that's probably the hardest part to figure out is like when they don't match, what do you do, right? Like you have to figure out the different options, and you would actually try all 3 of them right?
Yeah.
And then you would recurse through those 3 options, and then you would take the minimum of those 3, right? So
I see.
which one of those 3 operations will get you the
the minimum
operations?
right? Oh, okay. Yeah. I think the recursive step is even more confusing than the base. The base, I think eventually I should be able to figure out, but
right.
but the recursive
Yes, this is the
step
hardest
is
part, right? The recursive
yeah,
part is
it's
thinking about
even more
what
confusing.
happens.
Yeah. Do you mind I copy paste the solution so that I can think?
Yeah, of course.
That would be great.
So the cool thing is this problem, right? The recursive is like maybe one of the initial ways that like but as you know, like whenever it comes to a recursive function, there's probably going to be ways to optimize it, right? So you can do a memorization, and then it turns into
which
like
is
more dynamic
programming.
programming. Which
That's
becomes
right.
TP. So it all boils down to that once you figure out that problem, right? So this is
great. Thank you.
This is lead code number 72, I believe.
72. Okay, I do have access to that. I'll take a look. Is there a solution? I don't recall. Is there a solution for this 72 this problem?
I mean, there is a solution if you have the premium, but you can just look at the discussion section.
Sure.
Yeah, I think here's the link. I think I probably saved it here, which I think this is a good one. This one here.
Oh, did you send me something?
Yeah, I sent it. I posted it in the chat. Not in the chat, but the code here.
Oh, okay, sure.
Did you not see?
Oh, okay. Give me 1 second. Yeah, I.
Oh, right there. Yeah. It's right underneath my solution.
Oh, great. So let me copy paste the whole thing. So
yeah,
I was looking in the chat, but anyway.
Yeah.
No worries. Okay, great. Thank you so much. Thank you so much. Great. Definitely. That's a very good question. I really like this question. That really make you think. Before you go, I have some quick questions.
Let's not delete. Did you delete everything?
I already copy paste in the notepad. No problem. I already copy.
How about you? Yeah. How about you? Can you paste it back so that
sure,
I have
definitely,
reference as well? Yeah.
Definitely. Copy. I paste it back. No problem. Yeah.
Yeah. Thank you.
Yeah. Sure.
Cool.
Thanks.
Yeah. So, just for the rest of the feedback, right? I think, I think once the recursion kind of comes in, it all boils down to kind of how you break down the problem, right?
Right.
And so, like, I think one of the takeaways that I think you can probably do is when you come up with an example like this, try to think about the base case, right? Like, think about the most simple example, right? And then, like, you can try to think about what kind of questions did I ask you to try to get you to think about, how this should work, right? So what oftentimes when you're stuck, right, you don't know what to do because there's a lot of things you're thinking about, a lot of different strategies or maybe things that you could try, right? So you're kind of like either overwhelmed or you don't know what to do, right? And when that happens, the best way to unblock yourself is kind of ask yourself some questions or try to break down the problem, right? Okay, so and then you can review this thing and think about, okay, what questions did I ask you to kind of help you think about, okay, the first one is, let's think about the smaller base case, right? And what operations do I need on this, right? And what happens if I'm comparing this and this, right? So like, it's all very specific base cases, specific breakdown of the question, which will help you kind of, slowly break away the solution and think about how to go from there, right?
Good advice. Yeah, good advice. So I use a simpler example, maybe
simpler
easier
example.
for me to figure out the pattern here than come up with.
And you always want to try to think about like, what is the next step, right? So it can be and a lot of times why people get caught up with like not knowing what to do next is because they're thinking about, how do I get to the final solution, right? Like
exactly.
But when they do that, they're skipping a lot of steps in their mind, right? Think like you skip completely a bunch, like 10 steps before you get to the solution because you're thinking about how to get to the end. So think about, before you get to there, think about each step. Okay, what's this next smallest step to break down this problem, right? And in this case, like, okay, once we get to here, okay, let's think about smaller. Okay, you're comparing one character to the next character. Now, what are the operations, right? Like, and think about that way, right? So yeah, all these like little questions and what things that I asked you, you can maybe review and kind of see like what kind of questions I ask you to kind of try to help unblock yourself and thinking about these base cases and go from there, right?
Okay.
Yeah.
Okay. Really appreciate that. Good advice. Before you go, I have some quick question, general questions.
Sure.
So I think that recursion, for DSA, for the data structure and algorithm interview, I think recursion and dynamic programming is really a kind of a difficult part for me. So do you have any? So how do you practice and improve upon those kind of questions?
I think at that point it's more about practice. Like you just see, if you just do more of them and see like more of these types of problems, and like it's very similar, right? Like another question could do almost like a very similar thing where the recursion is like you're checking one character and then going to the next, right? Like and then having multiple like routes, right? So this is like having multiple routes. So I think every problem you do, you can have a takeaway of what that is, and then also, I don't know if you use the Neat code before, but this website I think is really good, which kind of identifies, right? If you go to that website,
it's called a Neat code.
Yeah, Neat code.
Neat code.
Which so I sent it in that thing there.
Great. Yeah.
But he basically splits up all the problems into specific like categories. If you go to the practice part, he has like his like 150 questions to do, and so I think what's helpful is going through the specific topics. But for that one, like recursion is like actually a tool, so it's done in many different ways. It can be trees or backtracking or graphs, right? Like or dynamic programming. So it's done in multiple different things. But the good thing is like it's done one way and there's multiple different solutions. So if you can think of other solutions to do it, then you can go ahead and do those too. So it's just like, I think it's just more about practicing to see like, okay, what are like in this case, right? It's all about the base cases, and that's actually most, like I would say 80% of like recursion problems is thinking about what are the base cases, and then how would you go about breaking up the problem after that, right?
Okay, sounds good. But when you try to come up with solution, how do you determine whether to use iteration or recursion, right? So because I think
that's personal preference, right? Like it's whatever you're more comfortable with. I always try to do more iterative over recursion,
right?
Just because it to me it's more intuitive. So it's up to you, right?
But recursion does have some overhead, have some cost. Like you have to do like a cost stack. So sometimes it's more efficient to do a iterative approach.
Absolutely.
Right?
Yes, absolutely. So you can call that out and try that. But like every recursive solution, there's an iterative solution to do that, right? So it is possible. That's right.
Right, and also backtracking. I mean, in the live class and also in the test review, they talk about the template, right? So in the template, they come up with they use a template. Then part of the template is like there's a backtracking. So is backtracking always used with recursion or?
Most of the times, yes, because it's a little bit more difficult to do that with iterative method. It's possible. Like if you've done n queens, the problem n queens before, it's possible to do that using an iterative method. It's just actually a little bit more difficult. So
I see. So basically, you're saying that it is possible to just come up with a recursive solution, but without backtracking, right?
Yes.
Okay, sounds good. So by the way, in the recursive function, does that always have to return something? Because most of the solution because in the call stack, right? So if in the call stack, usually I just try to figure out how the call stack works, right? So is there always the recursive function always return something, like return true or
It's not
false? Return...
always, right? It's kind of what what your need is for the problem, right? So I mean, most of the times it is to return something because you're doing some kind of operation to do it. So yeah, most of the times it is, but it's not necessary. But like I said again, this problem, like, it's very possible to do it in a iterative solution, probably using like a queue stack kind of thing, right? That's like the way to do it, right? So yeah, it's really up to you or your personal preference. Like for me, trees, I always do it iteratively. I never do recursion on tree problems, just because I find it much easier to do queues and stacks. Yeah, so that's just me personally.
I see. So do you think like draw pictures, like tree like picture would help with those recursive kind of
yeah, it's more like what I did here, right? So like so I drew out exactly what the call stack is, right? This is kind of like the tree like structure. So if you do this as well, like that would actually help you as well.
Okay. Sounds good.
Okay.
But your previous point, you're saying that recursive function it is possible for recursive function does not return anything. Is that correct understanding?
Yeah, recursive function, like by definition, is just calling itself, right? So
calling itself, yes.
There's no like requirement that it has to return something.
Okay, gotcha.
So yeah, for these kind of recursive functions, it's most likely going to be some sort of exponential function, and you can probably read up a little bit on those, on what the exact time and space complexity is for that. So